Hello! Ready for Chapter 2? Section 2.1, Linear Equations in Two Variables. So I'm going to start this out with an example. The rent for a two-bedroom apartment was $800 in 2018 and $1,100 in 2020. The rent for a two-bedroom apartment appears to follow a linear growth pattern. What is the rate of change per year for the rent? And what will the rent be in 2021? Okay, so we have these two data points. We have that in the year 2018, the rent was $800, and in the year 2020, it was $1,100. And a linear growth pattern would mean that it follows a straight line through these 2 points. Now, in the real world, some things work like this and some things don't. And you can't tell just from 2 data points whether they do or not. But in this example, we're just seeing what will happen if we have a situation that does work like this. If it does follow a linear growth pattern, that means that whatever it is that's changing over time is changing at the same rate. So here that means that the rent would be going up by the same amount each year. And what is that amount? Well, it increased $300 over 2 years. From $800 to $1,100 is an increase of $300. You can get that by subtracting. And 2018 to 2020 is 2 years. You could also get that by subtracting. So then $300 over 2 years, when you divide, that comes out to $150 per year. So if the pattern continues, we would expect in the year 2021 that the rent would be another $150 above what it is in 2020, which brings us up to $1,250. And you can see on my graph that the equation for this line would be y equals 150x minus 1900. That's an equation where if you plug in 18 for x, you get 800. If you plug in 20 for x, you get 1100. If you plug in 21 for x, you get 1250. And we're going to see in this section how to come up with an equation like that from whatever data points you start with. Now, here's an example. It doesn't really stand for anything. It's just an equation. Here the equation is y equals 2x plus 1. So whatever x is, the y that goes with it is 2 times that number plus 1. So for example, if y is negative 4, 2 times negative 4 would be negative 8, plus 1 is negative 7. If y is positive 5, 2 times 5 is 10, plus 1 is 11. And as we move along this line and visit the different points that make up the line, the y-coordinate of any of those points is always going to be 2 times the x-coordinate, minus 1. So if we go from one point to another, every time x increases by 1, like from negative 1 to 0, or from 0 to 1, or from 1 to 2, the y-coordinate goes up by 2, like from negative 1 to positive 1, or from positive 1 to 3, 3 to 5. Let's pick a couple of points on the line. It doesn't really matter which points we pick, so I've picked the points 1, 3, where x is 1 and y is 3, and then 3, 7, where x is 3 and y is 7. Now notice what happens as we go from one of those points to another. We went up 4 units, from where y was 3 up to where y was 7. 7 minus 3 is 4. And we went across 2 units. We went from where x is 1 to where x is 3. 3 minus 1 is 2. And how far we go up is often referred to as the rise, and how far across we go is called the run. So here the rise was 4, the run was 2, and if we divide rise over run, that would be 4 over 2, which is 2. That's the number in front of the x in the equation, and that's not just a coincidence. We could pick any 2 points on this line and calculate the rise and the run to get from one point to the other. And for this line, that would always come out to be 2. So that 2 is the slope of this line. The slope is a number that measures the direction that the line is going. And you can think of the slope as telling you how fast you're going up as you go across from left to right. So with this particular line, we're going up twice as fast as we're going across. Y increases twice as much as x does as we go from any one point to any other point on this line. So in general, the slope of any line can be calculated by taking any 2 points on the line. So we can call the first point x1, y1, and the second point x2, y2. The slope would be the rise divided by the run, rise over run, the rise being y2 minus y1, and the run being x2 minus x1. Now, it doesn't really matter which point you call point 1 and which point you call point 2, but you do have to be consistent. The y that comes first on top has to go with the x that comes first on the bottom. So the y2 minus y1 is the change in y, and in some books you'll see that written as delta y. That triangle-looking thing in front of the y is the Greek letter delta, and when you see that in math in front of some other symbol or variable, it refers to how much that other thing changes. So we have the change in y, or delta y, on top over the change in x, or delta x, on the bottom. Let's look at some specific examples and calculate the slope. What's the slope of the line that passes through the points 3, 6 and 5, 12? So y2 minus y1, the second y minus the first y, is 12 minus 6. The second x minus the first x would be 5 minus 3. So 12 minus 6 is 6 on top, 5 minus 3 is 2 on the bottom, and then 6 over 2 is 3. So this is a line with a slope of 3. We go up 3 for every 1 that we go over. We rise 3 and run 1 to get from one point to another. What about the line that passes through the points 1, 7 and 5, 9? And of course, remember, you're welcome to pause the video and try to work it out for yourself before I show you the answer. But that would be y minus y on top over x minus x on the bottom. Don't forget to put the y's on top and the x's on the bottom. So 9 minus 7 over 5 minus 1 would be 2 over 4. And in lowest terms, that would be 1 over 2, 1/2. So this is a line with a slope of 1/2. We go up half as fast as we go across. Notice that this isn't nearly as steep as that last line that had a slope of 3. The bigger the slope, the steeper the line. What about the line that passes through the points 1, -3 and -2, -1? Same kind of calculation. Be careful with the negatives. On top, we take -1 minus -3. And on the bottom, we take -2 minus 1. And remember, minus a negative is the same as plus a positive. So -1 plus +3 would be 2. -2 minus 1 would be -3. So we have 2 over -3, but a positive divided by a negative comes out negative. So I'll just say this is -2/3. So here we have a line with a negative slope, and it's going down as we go along from left to right. Here the rise over run is negative 2 over 3. So to get from one point to another, we can go down 2 and over 3. What about the line that passes through the points negative 1, 4, and 3, 4? If we do the calculation here, we take 4 minus 4 over 3 minus negative 1. That's 0 over 4, and 0 divided by any other number is 0. So this is a line with slope 0. Here, as we go along from left to right, we don't go up at all. We just stay at the same level. So that's what it means to have slope 0. The line doesn't rise at all. It just runs. What about the line that passes through the points 5, 2 and 5, 6? Here, if we do the calculation, we take 6 minus 2 over 5 minus 5, which works out to be 4 over 0, and 4 divided by 0 is undefined. So here we have a line where the slope is undefined. It doesn't have a slope. The slope doesn't exist. If slope refers to how fast you go up as you go along from left to right, well, that doesn't really apply here because we can't go along from left to right. This line is all rise and no run. So a vertical line like this one has an undefined slope. So here are the possibilities. Here are the types of slope that a straight line can have. If the slope is a positive number, then you've got a line that rises from left to right. So as you go along from left to right, the line heads upward. If the slope is a negative number, the line falls from left to right. As you go along from left to right, you're headed downward. If the slope is 0, the line is horizontal. It just goes right straight across. And if the slope is undefined, the line is vertical. It just goes right straight up and down. Now, how would you graph the line that passes through the points negative 3, 1 and has slope 2/5? Well, start by finding where negative 3, 1 is. Then the slope being 2/5 means that if we start here, we can rise 2 and run 5 and get to another point on the line. So if slope is rise over run, here that's 2 over 5. So I went up 2 and over 5, and then I can just draw the line in that goes from this point to this one. How about this one, the line through 0, 4 with slope negative 2? Start by finding where the point 0, 4 is. It's on the y-axis. Now a slope of negative 2, if you want to think of that as something over something else, it would be negative 2 over 1. So the rise over the run would be negative 2 over 1. Rise negative 2 means we go down 2, and run 1 means we go over 1, and then just connect the dots. Draw the straight line. Now I'm going to end this video here, and we'll come back in the next video and look at some equations for straight lines.